Hello guys. Sorry for the delay, and also I have to say sorry for my voice because I'm a little bit ill, but hang with me, I have some really interesting things to show you. And it's a pleasure being here with you at this very special for Chaos Group event. And it's very special because 10 years ago, Vlado and Peter released the first version of Vray. And right after that, it changed the CG industry with its speed, accuracy, and its photorealism. And right after that, a lot of updates of Vray started coming out. And we have to appreciate the hard work of a really talented developers team. There's something else. On the other hand, here you are, our customers. So your feedback and your support throughout these years has always led us on the right path, on the right track. So for that, I want to thank you before we continue. Okay, so my name is Konstantin, by the way, and I'm one of the 3D artists working for Chaos Group. And today we are together for the next 1 hour or so to celebrate this 10th anniversary of Vray. And what is the best way to do it? I think by taking a look at the latest developments at Chaos Group will be just perfect. So I will start with 3ds Max. After that, we'll take a look at Maya for a little while, and at the end, I will show you a couple of things in Vray for Softimage. Okay, so without further ado, let's jump into 3ds Max. Okay. So throughout your everyday work, the most important thing when you do your lighting and shading, sorry, before you start rendering is, in my opinion, interactivity. And the tool that gives you interactivity with Vray is, of course, the Vray RT. And I'll show a couple of examples of the RT in action. So let's take a look at those. Okay, so here I have a car, and also I'm using an HDR image for the environment. It's quite a high polygonal car. Also I have a lot of texture. So let's take a look at the performance of the RT. I'll start it. And once it loads the scene in the RAM of my computer, it will give me an immediate preview of all the changes I do. So if I rotate the camera, you will see that the response of the RT is just amazing. So you can immediately see everything with materials, textures, depth of field, and so on. And what I want to emphasize is that for us in Chaos Group, the most important part is to give you the same exact image using the real-time rendering solution and the production renderer. So you can rely on the fact that if I hit render now with the production renderer, you'll get the same exact result. The only difference is that the RT is a progressive path tracer, so it will produce a quite noisy image in the beginning, and after that it will clear it out. So let's take a look at something else. Now I'm just rotating the camera, but if I want to set up a material for my car, let's take a look at how the RT will give me feedback all the time throughout the whole process. So if I want to set up a car paint material, what I need to do is create 2 layers, the base layer of the car paint, the metallic paint, and after that the lacquer on top. So let's do it real quick. I'll use this slot for the base material. And for the purpose, I'll use a Vray material, set the diffuse color to black, and choose a color for my car paint. So I'll make it some sort of blue, like so. And after that, the base layer of my car paint, of my metallic paint, should be glossy, so it should reflect blurry. And I'll set my reflection glossiness to 0.7, let's say. And also I'll remove the specular highlights because I don't need them at the moment. And you can see that an effect like blurry reflections, which is quite hard for the production renderer to calculate and quite slow, can be rendered in a couple of seconds with the RT. So the process will be quite intuitive. Let's set up the second layer. I'll use this slot in the material editor. Again, a Vray material, which will be quite polished, like so. And now the only thing I need to do is to blend the two materials together. And the best way to do it is with the Vray blend material. So let's create a Vray blend material in the scene. And I'll plug the two materials in their corresponding slots. And after that, apply the blend to my car. So now we get a blend between the blue material and the shiny material, but this blend is controlled by this grayscale value in the options of the blend material. So if I set it to black, we'll see 100% of the code, and if I set it to white, if I set it to black, we'll see 100% of the base. And I don't want this behavior. I want to be able to blend the two materials based on the viewing angle. And I can do so by plugging a texture in the blend amount. For the purpose, I'll use a fall-off texture and change its mode to Fresnel. And when I do so, we get quite a nice looking car paint, and it's rendered quite quickly. But of course, the process of setting up this shader was quite long, and if I don't want to go over this whole process, over all these steps, I can create a Vray car paint material, which was added in Vray 2, and work from there. So here I have a car paint material in the scene already. If I apply it to the car, you'll see that the car paint material has all the blending required set up for us, so we don't have to do anything. And if I take a look at the options, there's a base layer of the car paint material. On top of that, we have a flakes layer, and yes, we have a flakes in our car paint, an effect which was quite hard to get without this material. So I hope you can see the flakes right here. And on top of that, we have the coat layer. And since you have a lot of options to set these layers up, I don't want to go through all these options. I'll just tell you a hint. If you want to remove the flakes from the car paint material and work as if with the simple Vray blend material, you just have to set the flake density to 0. If I do so, the flakes will be removed from my car paint. Of course, all these parameters can be mapped. You can use textures for them, or the Vray car paint material can be used together with the blend material in order to create more sophisticated results. So if I take a look around my car, like so, you will see that it is in an old warehouse, sort of. And we would normally expect some dust to be visible on top of my car paint if the car has been there for a while. If I want to create an effect like this and still use the car paint material, car paint shader, then I can plug it in a blend material, and on top of that I can add the dust, for example. It can be snow, it can be ice, it can be whatever. So let's apply the material, and you can clearly see the sort of a dust effect. It's quite a simple shader, but still we're getting there. Okay, so throughout this whole process, RT was helping me quite a bit. But keep in mind that every time you're dealing with setup like this one, where you have an object and surrounded by an HDR image, this is the easiest thing for a progressive path tracer to render. So this kind of progressive path tracing engines, they're rendering this type of images quite quickly. We can make it harder for Vray if we try to render an interior setup, for example, where light has to bounce a lot of times in order to illuminate the whole room, for example, if we're in an interior. So let's take a look at an example like that. So here I have a room which is quite high polygonal, and all the lighting is coming out of the window, through the window, I mean. So let's start RT and take a look at the performance. And yes, my image has been rendered, but you can see that it's quite noisy still. And in cases like this one, you can always right-click in the 3ds Max frame buffer and say Draw Region. And if I select the region from my image, you can see that Vray will only render this image, only this region, clearing it quite quickly. So another cool thing which was added to Vray 2 Service Pack 2, which was released, I'm not sure when exactly, but it was released during the winter. Another cool thing which was added is this real zoom feature. Again, if I right click and activate the real zoom, I have the ability to pan in the frame buffer and zoom in the frame buffer without having to change the position of my camera. So you can basically move the camera in the frame buffer itself. And for example, if I want to work on the material of this small table near the couch, I can zoom into the table without changing my perspective, work on the materials right here, use the region if I decide to, and after that, by double-clicking, I can just reset my view and render my image from my camera. So this is something really handy, and let's take a look at another example. Okay, so I'll use this one. Okay, so we have an empty scene here, so let's bring our car in view. And what I want to show you right now is you clearly know that Vray can render using the CPU, or it can also render using the GPU. Before we had only the OpenCL version of the GPU RT, of course, you know, it worked fine, but it had a lot of limitations. And in Service Pack 2, we actually improved that a lot. So we added blend materials, we added procedural textures which are supported by the RT GPU, and all these effects are quite hard to handle by the GPU of your computer, I can tell you that. So they were quite a challenge for our developers. But right now we decided that we can take advantage of the native NVIDIA program language, so to speaking, and we added the CUDA support. So basically the whole code of the OpenCL was rewritten and supports CUDA right now, and this version of Vray will be Service Pack 3, which is released today, and it will be available for all Vray 2 users. So you better get online and download it right away and try it out. You probably know that with the OpenCL version, the first time you start the renderer, you had to build the OpenCL trace program, and this took a while. Now with the CUDA, you don't have to do it because it's a native thing for NVIDIA boards. So by selecting CUDA, let's start the active shade, and you'll see the video card of my computer rendering the image out. Keep in mind that we always recommend people having more than one video card on the computer that's rendering, because it's best if you can have one video board for the viewport and the other one for rendering. And I don't have two video cards right now, so I might experience a little bit of lag in my viewport, but otherwise you can see that the rendering goes quite fast. It goes quite fast. Keep in mind, I'm just using one gaming board at the moment. If you can afford a really powerful video board, it will be extremely fast. And if you can have more than one, it will be perfect. Let me show you something else, and I'll open the material editor. Just to show you the material of the car, you can see that the material of the car is the blend material that I showed you earlier. So you can now create really sophisticated shaders with RT GPU also. And another thing I want to show you, it's another new feature added in Service Pack 3. If I take a look at the options of the RT, you can see that now we have the ability to render motion blur. And this was a possibility before with standalone, and now you can do it through the interface. If I activate motion blur and hit render, it will take a while till Vray exports all the geometry, all the information, because I'm taking 10 geometry samples of this geometry in order to get this nice round effect of the rim. But still it's quite fast, even though I'm sampling a lot of geometry and I'm shooting a lot of rays in order to get this motion blur going. And of course, with the motion blur active, I can start rotating the camera and we'll be able to see the effect from all angles. Okay, so these are great improvements, and I'm sure you will take advantage of those. But I rarely see people using RT as a production renderer, and this is something really useful. I want to show you that right now. So basically, if I go to the Assign Renderer rollout of 3ds Max, I can select a production or an active shade renderer. And normally people would select RT as an active shade renderer. But if you actually select RT as a production renderer, the next time you hit render, it will render each frame of your animation. If you have animation, save it on the hard drive and continue with the next one. So this is how you can use RT for previewing animations, and it's quite cool, especially now with this motion blur effect added. And here's a really simple animation that I rendered on this computer. It took less than 30 seconds per frame. And let me find it. I'll use PD Player to preview the animation. So here we have quite a complex object with all blend materials, a lot of textures, depth of field also active. So if I go like this, you can see that here my object is out of focus, and here it's in focus again. So I'm using also depth of field. So this is quite handy if you want to have to run a fast test render, see your whole animation. It will be noisy, but it will be perfect for preview purposes. So this is just an idea that I'm giving you right now. So let's take a look at something else. I want to show you a couple of options of the Vray material, and also a couple of new textures which are added with Service Pack 2. So what I have here is a ring with a diamond on it, and if I render, and I'll be using the RT throughout this demonstration. If I render, you can see that it looks fine, but I can tell you right away that something's missing. And the thing that's missing is, in reality, when light passes through a transparent object, you would expect it to be divided into its basic colors, and you will be able to see some sort of a rainbow effect. With Vray, in order to get this effect, first of all, you have to be a Vray 2 user. And the second thing you need to do is select the material, the diamond material, and activate dispersion. And immediately after I do so, you can see that now the light ray is divided into its basic colors. And the dispersion set to 50, which is the default value of the dispersion, is the physically accurate dispersion. If you want to have a stronger effect, then you have to increase the ABI parameter that you see right here. If you want to see less of the effect, then you have to, if you want to see more of the effect, you have to decrease it. And if you want to see less of the effect, you have to increase it. So let's render with the production renderer, and I want to show you something else really cool. And it will take a while. So one more example why the RT can be extremely useful. Okay, so it's almost done. And done. So one more thing. One more thing that you can do in order to improve the quality of your image is add a lens effect. So in reality, if you take a photo of an object like this one with such a strong reflections, then you would expect some sort of glow surrounding the brightest areas in your image. And before you could do that with the Vray lens effects, which are accessible through the environments and effects menu, but in my opinion it was not that handy because you always had to keep two windows open. That's why we decided to move the lens effects in the frame buffer itself, and this is an option that I'm not sure when exactly it will be released, but it will be released because it's working already. Here I can open the lens effects from my frame buffer, and if I start tweaking the bloom strand, then you'll be able to see the bloom effect. If I want to have a glare effect added to my image, I can increase the weight of the glares. And another thing about glares is that I can turn on diffraction and you'll see sort of a rainbow effect, something quite realistic. And you can see that now it's quite handy to work with the lens effects like so. And also keep in mind that the lens effects are saving a render element that can be later used in post-production if you decide to. So let's take a look at a couple of textures now that were added to the service. Some of them were added to the service pack, some of them were added to Vray too. So what I did with that scene, I'll show you outside of 3ds Max. So I'll go, let's say here. So I brought this model of a van into Mudbox, and after that I prepared it for PTEX painting. And you probably know what PTEX is, so I don't have to explain it. But after that I painted textures on top of my model, some sort of graffiti. And after that I have the ability to render this PTEX file, which was exported from Mudbox inside of 3ds Max. And here is my model, and here is the material of the model. In order to load the PTEX file, I need to use the Vray PTEX loader. It was added to Service Pack 2. And right after that, I can just hit render, and you'll see the texture being rendered with Vray with no problem whatsoever. And of course, this is a really cool feature. You don't have to have UVs on your objects in order to paint textures on them. And you can see that I'm using multiple bounces of GI. The PTEX is not leading to any sort of delays or slowdowns. Okay, and another really cool texture that I really like to use is the Vray distance texture. It was added to Vray 2, so let me show you what you can do with it. First of all, the distance texture is similar to the Vray dirt texture. The only difference is that the Vray dirt texture was not able to do effects like displacement based on distances between objects because it required actual ray tracing in order to create its effect. That's why we added a new texture, which is called the Vray distance texture. It doesn't require ray tracing, and you can actually displace objects based on the distance between them. So if I activate the 3ds Max displacement of this plane, you'll be able to see that it's displaced based on the distance from this sphere. So quite a handy effect, and if you're creative, you can create really interesting things with that. For example, I used this same texture in order to get a real-time render time Boolean operations. And I'm using the texture as opacity, and if you link it right, you can get this sort of effects. Okay, so what else? Okay, so what I want to show you right now is another cool thing that was added to Vray 2 Service Pack 2, which is some cool things in terms of hair. So here I have a really simple example of 3ds Max hair, and if I render it out, you will see that Vray will create geometry based on these 3ds Max hair curves, and right after that it will render the hair as it should look like. But now I'll show you really something really nice right after rendering that. So you can see that the hair is great, but the shader that I'm using right now is a new shader added in the service pack. So let's take a look at that. So here is the shader for my hair, and you can see that this shader is quite complex. It has a lot of layers, so you can create really sophisticated effects. It has diffuse parameters, it has 2 specular layers, and also it has a transmission layer, which will help you create some sort of subsurface scattering with something you'd expect with hair. And you can get backlighting also. Okay, but what about if I want to shade the hair to have different colors along the length of the fiber or the hair? If you want to get an effect like that, you can use a new texture added in the service pack, which is the Vray hair sampler node. So I'll use this texture in the overall color. I need to find it, of course. It's called Vray hair info texture. Sorry for that. So I'll use the Vray hair info texture and change one of the colors to white and the other one I'll set to red. Let's render again. Before I render, I just want to style the hair a little bit so you can see it better. So I'll cut the hair like so. And with the help of this texture, I can get different colors along the length of the hair or the strand. And this texture has a lot of cool options. I'll leave them to you so you can experiment with them, see what kind of effects you can get. This is just an example. And another really cool thing about this shader and the whole hair workflow is that now Vray supports the Ornatrix plugin, and it works really fast with it. This is quite a popular 3ds Max hair plugin. So here's just a simple example of the hair from Ornatrix rendered with Vray. And I can tell you that the exporter you can export millions of hairs for no time whatsoever. And the same shader and texture are also available in Maya. Okay, so since our time here is limited, I will jump from 3ds Max into Maya because I'm sure we have Maya users right here in the room, and I'll show you a couple of the cool Vray features there. Also keep in mind that I'll be mixing older and newer features since it's the 10th anniversary. And I always like to show my favorite features during this type of presentation, so you'll see what I mean. Okay. So the first thing we'll do in Maya is take a look at a couple of examples of the RT. And I don't want to bore you with simple examples, I'll just jump to the production stuff. So let's take a look at a couple of examples of production type setups. So here I have a similar car as in 3ds Max, but this time we have a real environment with buildings, a lot of textures and such. So, and also depth of field is active. So let's take a look at the result. I'll just start IPR, which is the RT. And I have some video board issues, but don't worry about it. Okay, so right now my CPU is rendering the image, and you can see that even with the CPU it's really fast. It's clearing the image quite quickly. And RT can be used with distributed rendering, so if you have more than one machine, you can use the CPUs or the GPUs of all those machines. And if you want to see an example of that, visit us by our booth. We have a lot of machines at our disposal, so we can show you that, and we can show you the performance. But you can see that the RT can also be used for production purposes. Just for a couple of seconds the image is clean, and I can save it on the hard drive and work from there. Okay, so another example of the RT will be the RT running on GPU, so let's take a look at that. Now use this one. Again, you can take a look at all the time. You can take a look at what's going on in the Vray standalone, and you can see that the RT has to load all the textures in the GPU. Another really important thing is that if you're using really heavy geometries and if you're using a lot of textures, you have to make sure that your video board has enough memory in order to load all this information and render it out. That's why we recommend using these video boards with bigger, larger memories, like 4 gigs, 6 gigs, 8 gigs of RAM, because then you have no limitations with your scenes. Otherwise, you can see that gaming boards also work fine, and they're rendering the images quite quickly, since they have a lot of CUDA cores also. Okay, so let's change the view and take a look at the same thing, but with depth of field. Okay, so this is a different view also. I'm using the filter for the camera, that's why it's kind of reddish. And you can see that even with depth of field, the RT can give us quite a quick preview of all the changes I make, everything that will be visible with the production renderer. So let's take a look at some options of the production renderer since we're at it. And I'll start with talking a little bit about dynamic geometry. And with Vray, you have 3 types of dynamic geometry that you can render. The first one is render time subdividing. If you have low polygonal meshes, you can subdivide them during render time. You have displacement, and you have the Vray proxy. For all these dynamic geometries, the same rule applies. Only the geometry that is visible in the bucket, which is being rendered at the moment, will be loaded into the RAM of your computer. So using dynamic geometry with Vray is extremely fast and extremely memory efficient thanks to this algorithm. So let's take a look at a couple of examples. And you can see that I'm using close to production examples. I'm not trying to trick you. So we have really heavy scenes, not just cubes and spheres. So here's an example of a different scene. And I have this alien right here. A common approach, a common thing that people will do is model things like the head of the alien in ZBrush, and after that export displacement and load it here. So let's take a look at displacement renders with Vray. I have a material with the displacement already applied to it. I'll just use it for the head of my character and click render. And you can clearly see that with no delay whatsoever, we get really detailed displacement. I'm actually not using bump maps, no tricks, only displacement. I have ambient occlusion to show you the cavities, but that's it. Basically, using 2D vector displacement is possible in Vray, so you can render vector displacement. You can render 32-bit displacement maps, which can be created from ZBrush, Mudbox, or other applications. Okay, so this is a simple example of the displacement. Let's take a look at another one. So I'll enable a layer and apply material with displacement to this layer. So, okay, so if I render, you'll be able to see the displacement that I'm applying to this ground plane. So it's like that. And in fact, there's something else interesting that I have here. And you can see that these inner parts of my geometries are missing. And they're missing because I'm using water level at the moment, which is a feature of the Vray displacement. The water level allows you to cut out all the geometry that is displaced than specific value. And you can see that right now my water level is set to -2.9, which is exactly the level that I want to be cut out. And instead of using opacity maps, you know that opacity maps can be slow for rendering if you have a lot of them, one in front of the other. With the displacement itself, you can cut out all the unnecessary pieces of the geometry. And every time I create grills for cars or something else, I tend to use this feature quite a bit. So the third example of dynamic geometry would be the Vray proxy. And for the proxy, I want to show you first piece of geometry, quite heavy geometry, and after that I'll show you how to convert it to proxy and how to use this tool. Okay, it will take a while to load, and this is the robot from our boot. You might have seen it already, but it's quite heavy. You can see that the lock in the viewport is quite noticeable, and every time you have to deal with this kind of geometries, you'll get slowdowns, crashes, memory, not enough memory of your computer. So if I try to render it, I might run out of RAM and get nothing or get Maya crashing. So in order to render this kind of geometries, you can always use the Vray proxy. And if I want to convert this geometry to a proxy, I have to select it, and I will not do it right now because it will take a while, but after that I can go to Create, Vray, Create Proxy, and these are the options of the proxy. Basically, this geometry will be exported, saved on my hard drive, and during render time, only parts of the geometry will be loaded into the RAM. So this makes it extremely efficient. And also, I can export objects with animations on them. So let me show you this robot converted to a proxy. So this is what the proxy looks like. This poly cloud in the scene gives you a general idea of where the object is, so you can position it or scale it if you have to. And if I hit play, you will see that the tentacles of my robot are actually moving, and I can save this animation information with the proxy file itself. And also it saves velocity information, so you can get accurate motion blur and velocity passes out of that. So let's take a look at a more production example with the same robot. I'll open a scene, and we have a lot of these robots flying around. We have a lot of 10 million polygon robots flying around. So this will be something impossible to render with just geometry. And since these robots are proxies right now, I can just hit render, and you'll see that with no delay whatsoever, Vray will create the geometry and render it quite quickly. So it will start in a second. Here it goes. And this is the same exact model. And while Vray is rendering that, I just want to show the memory consumption. So right now Maya is using 1.5 gigs of RAM. It means that even if I had a 32-bit operational system or computer, I could render that, all this geometry. And it will work with instance geometry, or it will work with unique geometries. It's all the same for Vray in that case. So you can see that it's rendered quite quickly. And let me show you an animation of that. Oops. I'll use PD Player again. This is another software that we're selling. So let's play it. And PD Player will catch the animation in the RAM, and after that we'll be able to play it fluently. So you can see that the model is exactly the same, and with no delays whatsoever, I could render millions of polygons like that. Okay, so let's take a look at something else. Sometimes you cannot load your geometry in Maya in order to convert it to proxy. For example, if I export something from ZBrush, I want to load it in Maya, but Maya crashes every time I try to do so. I mean on the highest subdivision level. So if you experience that, we have an external tool that converts OBJs to proxies, and after that you can render them with Vray. And this tool is called Ply to Vray Mesh Converter. It's a command line, and it has really simple commands that you can use. Just write down Ply to Vray Mesh, drag your OBJ right here, and this external tool will create the proxy for you. And I have an example of that. So here's the same model in ZBrush, and it's quite dense. You can see that clearly. So if I want to render that in Maya without using displacement or anything else, I can do it. So I've converted the head to a proxy already. Let me open it and render it. Just find it. So it will take a while to load, but after that it will be extremely fast. So here's my geometry, here's the head. And I'll just hit render, and I'm rendering with GI. You'll see that no delays will happen. It will be rendered in a matter of seconds. And it's the same exact geometry, exported at the highest subdivision level. So if you model something really nice in ZBrush, you don't have to worry about displacements. You can just render it in Maya like so. Okay. So I have to choose one last feature to show you because we're running out of time, and I have to show quickly Vray for soft image. So let's say how to render elements. So one of the best things about Vray is the 32-bit workflow. So you can render everything in 32 bits, save it as an OpenEXR, save all the render elements with in one single file, and after that compose the same image that you see in the frame buffer out of diffuse, reflection, refraction render elements. So let's take a look at an example of that. So here I'm rendering a car, nothing special, but while I'm rendering, I can take a look at the different render elements that Vray is creating. So this is a diffuse, reflection, refraction. Also, we have really cool render elements like Z-depth. And here we have a facing ratio render element and such. So basically, once I have all these render elements, I can compose them in Nuke or whatever post-production software I'm using, and I can tweak the reflection amount, I can tweak the reflection blurriness, I can change colors afterwards without having to re-render the image. And we guarantee that when combining all these render elements of a linear image, you will get the same exact result as your beauty pass. So this is a really powerful tool. And you have a lot of render elements to choose from, but if you want to create a custom one, you have the ability to do it. And it is done through this Vray extra texture render element. So if I want to do an ambient occlusion pass right now, I can add an extra texture render element to this list. After that, I need to find it. Here it is. And in the extra texture, I can use a texture like a Vray dirt, for example. Let's try it with dirt. And the next time I hit the render button, we'll have one additional render element, which will be an ambient occlusion pass, basically. Here is my extra texture, which is the dirt, and which is my ambient occlusion pass. So this is how you do custom render elements. You just use textures, plug them in the extra texture render element, and you get all these custom render elements. Another really cool thing that you can do is create a reflection mask, sort of speaking. If I want to create a reflection mask, I'll use the same dirt, set the radius quite high, change the mode from ambient occlusion to reflection occlusion, and I'll invert these colors, add a little bit of glossiness, and I think that's about it. So I'll do something like that. I'm just changing the options of the Vray dirt, and you'll see the effect that we get. We basically created a reflection mask. It can be used in post if you want to change the background, or I can do a reflection mask only for the ground, only for the car, only for separate parts. So quite cool. And okay, so this will end my demonstration inside of Maya, and I just want to play a video which will demonstrate how Vray for soft image was used in production. ENTS, it's being used in production already. And the studio that created this video is called Boo Studio. They created a video in 3ds Max, and after that, since they're fans of Softimage, they tried to create the same video using Vray for Softimage, and they could do it. So I'll just play the making of this video, and you'll see what I mean. This was done in Vray for Softimage. And I have two more things to tell you, and we're done. So first of all, Phoenix, the fluid simulator, Phoenix FD, was released for Maya also. It's not released, sorry, it's in beta testing at the moment. It will be released in the future. But if you want to participate, check on our website. And one more thing, fill out your questionnaires. You will find them on the chairs, or you already have them. And you can come by our booth, and you will receive a t-shirt like mine right here, a Vray t-shirt. So I think that's it. And so again, sorry for my voice. I hope it was not too annoying. On the other hand, if you liked it, this whole thing will be recorded, and you can check it out on YouTube. What else? If you have questions, visit us at our booth. We'll be here till Friday. So thanks for the attention.